A particle P moves in a straight line such that its displacement x meters from a fixed point O at time t is given by x is t cubed minus 3t squared plus 8t. We want to find the distance of P from O at t equals 0, t equals 2, and t equals 4. Note that the displacement from the point O is the same as saying the distance from O. So we need to evaluate x at each of these times. If t is 0, x is going to be 0 cubed, take away 3 times 0 squared, plus 8 times 0, which is 0. This tells us that we're at O when t equals 0. For t equals 2, we have x is equal to 2 cubed, take away 3 times 2 squared, plus 8 times 2, which is 8, take away 3 fours, which is 12, plus 16, so 24 take 12 is 12 meters. When t is 4, x is equal to 4 cubed, take away 3 times 4 squared, plus 8 times 4, which is 64, take 3 sixteens, which is 48, plus 32, and this gives us 48 meters. We now want to find the velocity of P when t is equal to 1 and t equals 3. We have an expression for the displacement, so x is equal to t cubed minus 3t squared plus 8t. The velocity is the differential of x with respect to t, dx dt, which is 3t squared minus 6t plus 8. When t equals 1, we get that v is 3 times 1 squared, take away 6 times 1 plus 8, which is 3 minus 6 plus 8, which gives us 5 meters per second. When t equals 3, v is going to be 3 times 3 squared, take away 6 times 3 plus 8, which is 27, take away 18 plus 8. 27 take 18 is 9, add 8 is 17 meters per second. We now want to find the times when the velocity is 0. Velocity, we know, is given by dx dt, and we work this out in part b to be 3t squared minus 6t plus 8. For the velocity to be 0, we need 3t squared minus 6t plus 8 to be equal to 0. If we consider this quadratic equation and look at b squared minus 4ac, we have minus 6 squared minus 4 times 3 times 8. This comes to 36. Take away 12 times 8, which is 36. take away 12/8 on 96, which is minus 60. The fact that this is negative means that the equation has no roots. If b squared minus 4ac is negative, the equation has no roots. And this means that the velocity is never zero. So there is no time at which the velocity is zero. This is very important in answering the next part of the question. If the velocity is never zero, then the velocity must always be in one direction, since it cannot switch from being positive to negative without going through zero. We now want to find the distance the particle has travelled when t equals 4. The analysis we performed at the end of the last part of the question, where we decided the particle could only travel in one direction, is important here. Since to work out this distance, all we need to do is work out the displacement from O to the point where t equals 4. Had the particle been able to reverse, then the situation would be more complex. In order to work out the distance travelled by the particle, we would have had to work out this distance, then this distance, then this distance. So it would not just be equal to the displacement when t equals 4. But since we know the particle goes in a straight line, all we need to do is work out x when t equals 4. And we've already done this calculation in part A. However, just repeating the calculation, 64 take 48 add 32 gives us 48 meters. Finally, we want to find the acceleration when t equals 2. We know that velocity is 3t squared minus 6t plus 8. To get acceleration, we differentiate velocity, and this gives us 6t minus 6. When t equals 2, the acceleration is 6 times 2, take away 6, which is 12 take 6, which is 6 meters per second squared.